So now that you've heard a bit about asynchrony, and we've talked briefly about the pros and cons, let's zoom in on how Java initially tried to provide support for asynchronous communication. And that was with something called Java Futures. And you'll see that we cover this for a couple of reasons. First, it's interesting to know what futures are, at least historically, and because completable futures implement the future interface. So you can think about a completable future as being a superset of the capabilities provided by futures. So to understand that subset, it helps to understand what a future is. Okay, so futures were added to Java 5, which came out in the 2004 timeframe, and they were added to provide asynchronous call support. And there's this concept that was added in Java 5 called a task. We'll cover tasks a lot more next semester as well. But a future basically was provided to allow asynchronous operations and to support the whole life cycle of a task. So let's take a look at what you can do with a future. So there are 5 primary operations on future, which is an interface. And one thing you can do is you can invoke an operation asynchronously using various means, such as the thread pool executor's submit method. So you can submit work that will run asynchronously. And when you submit something to the executor service or the thread pool executor, you get back a future. And this future can be used to retrieve the results of a two-way task which is running asynchronously when the task is done. So that's basically what you're trying to do. And in order to do that, there's a pair of methods, get, which blocks if the result isn't done, and get with a timeout, which can be used to either poll or wait for a certain amount of time for the result to come in. Another thing you can do with the future is you can test it to see whether or not it's finished. So if you start something running asynchronously, it's chugging along in the background, and you're a client, you might go, is this thing done? Let me check. So you can ask a future, are you done? And that's the isDone method. And then you can also cancel a future, which is ostensibly going to make the asynchronous operation stop running. We'll talk more about that in a second. It's a little subtle. And you can also check to see whether or not a future has already been canceled, whether the operation has already been canceled. So once you call cancel, obviously it's going to try to cancel the operation. That may or may not work, as we'll see in a second. And it'll then mark the future as, it'll mark the operation as being canceled. So those are some of the things that you can do with a future. So the way you typically do this is you have asynchronous calls invoke an operation by submitting them, and they will continue to run in the background. You get back a future right away. So if you take a look at this example, I kind of highlight it. You can see how you make the call, you get a future back. Then you could make another call, get a future back. Then you can make another call and get the future back. And you don't have to block synchronously waiting for each of those calls to finish. Now you've got a bunch of futures, and you can go and check to see whether the computations are done, are canceled, etc. Or you could just wait and get the results. So here's an example. The executor service submit operation that I mentioned briefly can be used to submit asynchronous calls in Java. So this is how it works. Let's say we make ourselves a task. You can see that this task is something that's called a callable. And a callable is a very simple functional interface that has a method called call that takes no parameters and returns a value. So that's what a callable is. And you can see here that this particular callable defines a task which is going to create 2 big fractions and multiply them together. And we're going to go ahead and take this task, and we're going to submit it to the common fork join pool, which implements future, by the way. So a fork join task implements future. And in this particular case, we're submitting a callable. Remember I told you that fork join pool was an executor service, so you can go ahead and submit callables to it as well. So we go ahead and submit this task. You can see what it does is it takes the task and it gives it over here to the executor service, and then this thing goes off and runs and does its thing. As soon as you call submit, before any of the processing starts in the thread pool, that will return a future. So you get back a future to a big fraction in this particular case. The asynchronous computation can then go ahead and run in the thread pool. So we've got a thread pool over here, chugging away, doing some work on the task that has been submitted. It'll call the call method and so on. It'll run that method. And at some point, that will be done. But whether or not it's done yet or not, at some point, the client thread, the one who submitted it, may turn around and say, I can't make any more progress. I need the result of that asynchronous operation. And we'll talk a bit about this because this is a subtle issue. How long do you wait before you try to get the result? So at this point, let's just assume the client needs the result. So it goes ahead and calls the get method on the future, and that will then block if the result has not finished computing in a thread in the thread pool, and it'll then give the result back to the client when it's done. So get will block in that case. And there's a couple of different variants of get. You can either have a blocking get, and you can also have a timed, either a timed wait or a poll, where you can say, I'm only going to wait up to a certain amount of time before I give up and do something else, and maybe come back to try that future again at some point in the future. So those are the key operations. So you can see there's an asynchronous behavior going on between the invocation, the processing, and then the client getting the result at some point in the future. As I mentioned before, the results can occur in a different order than they were invoked. So that's good because it gives you better parallelism, but it may be bad if you don't expect the results to come back in order. Okay, so a future, a Java future, is essentially a proxy that represents the results of an async call. And here's a diagram that kind of illustrates what's happening here. This is sort of what I just showed you, just drawn a slightly different way. So the client invokes an operation. The operation runs in the background as an asynchronous computation. And then at some point, the client comes along and gets the results. And you can see that it'll wait until the result is done. And if it's not done, it'll wait. Otherwise, it'll go ahead and return the result. And the result is only obtained after the computation completes, or if it's a timed operation, when the timeout elapses. So you don't have to bound yourself indefinitely. I have a couple of really nice human-known uses of this, which I think are easy to understand. If you've ever gone to certain kinds of fast food restaurants. So if you go to certain fast food restaurants, like, say, Wendy's, where they cook every meal to order, when you order your meal, they will hand you a piece of plastic called a table tent number that looks something like this. It could also just be a slip with a number on it. But the point is that you get back something that is a future, right? So you go and you say, I want to have a Wendy's burger with all the fixins, or like go to BurgerFi, which is a popular place. You order your meal. You don't just stand there synchronously at the cash register waiting for your food. Instead, you order your food. They give you back a future. Maybe you order a drink. They give you a cup. Then while they're cooking your food, you'll go over and maybe fill up your cup, or you'll text your friends, or you'll have a conversation, or you'll read the newspaper, whatever you end up doing. And in the meantime, the cook is cooking your order asynchronously. And then when it's done, depending on where you've gone, either you have to go back up to the service pickup window and say, hey, is order number 12 done? Or maybe they give you one of those little beepers and it'll beep you when your order is finished. Or maybe you'll put the table tent number on the table, or you'll put it on some kind of a post. And then when the food is ready, they'll bring it out to you. There's a whole bunch of different ways it gets delivered to you, either polling or callbacks. And that's how the food gets to your table when your food is finished being cooked. So that's a good example of a future. That table tent number is a future. It's kind of a promise that you'll get what you want. And it's interesting because there are different ways to organize fast food restaurants. One way is sort of the Wendy's approach, cook everything to order. The other way is kind of the classic McDonald's approach. They've actually kind of changed this now, but back in the day, when you went to McDonald's, they would pre-cook, a Big Mac and fries, and they'd pre-pour the drinks. And when you would come up and say, I want a Happy Meal or whatever you were going to order, you would synchronously wait at the cash register. You'd place your order, you'd pay, and then the cashier would turn around to the cash, right? And they would take the Big Mac, and they would take the fries, and they would take the drink, and they would hand it to you. And you had a synchronous interaction at that point. That's synchronous communication, right? You're synchronous, you're blocking, you're doing a rendezvous, waiting for the result. Whereas the Wendy's approach uses futures and those table tent numbers or some other means to associate some asynchronous operation, cooking your food, with picking it up when it's finished. So that's a good way to kind of get your head around these different models of computation, and that really is a good example of futures. Okay, so that's the end of the quick overview of Java futures. We'll talk a lot more about how to use it and the pros and cons of this model in just a second.